So following on from our discussion about, space bots and all that, space bots with its programmable swarms of robots, it's a little bit nichey, that's quite nichey, right? But to me, that's way too mainstream. Okay, it's time to really double down on the niche.
Deeper into the rabbit hole.
It's time to go deep, right, into the world of electronics. Now, I love me a little bit of electronics. So Megaprocessor comes from, let me show you some inspirations, right? You remember The Imitation Game?
Yeah.
Right? There's this wonderful scene when Alan Turing is essentially inventing the modern computer without necessarily fully realizing it. He's inventing a device that's a reprogrammable machine and using it to break the German Enigma codes. And it's just this wonderful scene when he's stood in the room. It's like physicalized, He's stood in the room and his gadget is built there with all the cables flying out of it. So I kind of wanted to have that experience because there's a lot of problems that he had to solve to build that machine, I mean, he had to invent computing. He'd kind of invented computing a little bit earlier, and this is like a subset of it, and it was like an electromechanical device.
Yeah.
But nevertheless, there's a whole genre of games that I absolutely love where you solve logic puzzles that get increasingly complex. And they're often made by Zachtronics, which is a company that we often mention. And those guys are completely nuts in the games that they'll make, right? So Zachtronics, for those that don't know, I know you've never played any of them, but I love them, right? Like this is TIS 100, right? You see this?
Oh,
TIS
graphics, amazing.
Yeah, they are. They're absolutely brilliant, mate. That's why you're a producer, right? And you're not a designer, because this is gameplay through and through, right? And so this is a game where you program parallel processors using assembly language, right? Very popular. This is related to the discussion we were having earlier, right, about extreme niches. Who the hell plays this? But they do. And there was also Shenzhen IO, as this one's called, which is a game about putting together chips, microprocessors, and connecting them together. So each of these is a microprocessor.
Okay.
Right? And then on each microprocessor, you can put a little bit of assembly programming to read inputs and do some processing and push outputs, all in assembly. And the way that Zachtronics games always work is that you have a puzzle, right? And the first puzzle is really simple, like make this light blink on and off once a second, And the final puzzle will be something, 20 hours later, an obscenely complex piece of electronics that you can make. And Zachtronics has an enormous following, absolutely enormous. And I think it's because they found that niche of, I don't know what kind of gamer you would call that, like the engineering nerd gamer.
Yeah.
So I kind of wanted to make something like that. So I decided I would make a game called Megaprocessor. Let's fire it up.
Because I remember we had a conversation about building a computer years ago. I think even before the scanner and
yes,
Scanner Somber and Wrongwire.
That's right. Yeah, a long time ago. Yeah, I had this video game idea called Build a Computer, and the idea was that you would, and that's the idea behind this game. The idea is that you would start with like a transistor, a single transistor, and then from a transistor you would make some logic gates, like some AND gates and some NOR gates and things, and that would be the first few puzzles, and then in the later puzzles you would use those gates to make like a memory chip, or a or arithmetic and logic unit, and then you would slowly piece it all together until you had a fully functioning 8-bit computer. It stems from this concept, like Megaprocessor is actually a thing. If I can just find it, this is it. This is the Megaprocessor that the kind of core game idea comes from, right? So this is in the Cambridge Computing History Museum. Right? I live in Cambridge, so this is just around the corner from me. And this is an 8-bit computer built entirely out of transistors. Right? So each transistor is, it's like this size. Like they're not miniaturized transistors as you would typically use. And so by building an entire circuit board out of that. So this is an 8-bit adder circuit made entirely out of transistors. But the brilliant thing that this guy did, this completely eccentric electronics nerd, is he added a little LED to each input and output.
Right, brilliant. Yeah, okay.
So that when you're looking at the whole room, it looks like a giant lit up computer. You know?
Yeah.
So every one of these boards does something really specific, right? But they're all interconnected. And this one on the left that you can see says "Game Over." That's his 1 kilobyte of memory.
Right. Okay.
So his memory is his screen, effectively. By filling in memory at the right place, you can make it look like it's a pixel display. You know.
Yeah. Okay.
This is
So is that just binary, right? The memory's just on or off?
Of course, yeah.
Yeah, I'm with you.
And it's all just built from fundamental electronics, like first principles stuff.
Yeah. Well, I remember in our first year of our computer science degree at Imperial, we did a hardware course that literally, I think week 1 was P and NP silica or whatever it is, to build a transistor. And then I remember it went all the way through, and it was it'll never leave me. It was the best course I ever did.
Yeah, it's fantastic, wasn't it?
By the end of it, I was like, well, my degree's done.
Yeah. Well, you could, because you now understand how computers work at a really
Mm-hmm.
fundamental level. Because in the final month, you were taking like a chip which was 8 kilobytes of memory, and you knew that you built that. You knew exactly how that worked. You know exactly how it was operating. But now you could consider it as a black box, and just drop it into a much bigger circuit. And that experience of going through that, admittedly degree level electronics course, is exactly what I wanted to create in this game, Megaprocessor. Right? Mm-hmm. Now, you might say that degree level electronics is not necessarily fertile ground for a video game, but I disagree. All right, and so that's what I decided to make. So this is Megaprocessor, right? So you can kind of see straight away, I've kind of built a scene which is a little bit reminiscent of, firstly, that Megaprocessor at the museum, and also Alan Turing's giant machine, right? His giant code-breaking machine behind him. And each of these boards is like a self-contained puzzle, and they're interconnected, right? And this is like the challenge on the whiteboard over here, So it tells you at the top, build a circuit to count from 0 to 255, right? So I should point out, this is not a project. This is a project that I only spent about a month on this project, I think. So I didn't really it's not like Spacebots. I didn't get to the point where I had loads of levels that I could play and loads of scenarios. This is the only scenario. This was my test scenario.
This is a Unity build, isn't it?
Yeah, it's a 3D Unity game. And you can walk around this world and have a look at it. Because one of the key things in my vision for this game is I wanted you to build this computer, but I kind of wanted it to fill this room, Like I wanted all the logic boards to be around the edge of this room, stacked up with cables dragged from one to the next, And so you can kind of do that, like you can connect the output of that one to the input to this one, like this, and just build connections between boards. And so, and that was I didn't want it to be like a 2D schematic, I wanted it to be physicalized in the same way that Turing's code-breaking machine was, So, there aren't any puzzles and there aren't any tests. So I kind of have to invent it, and you have to imagine that it exists, because you can solve puzzles by connecting things together. Like here's some AND gates, right? So we're already a few steps into the game where we've already made an AND gate out of transistors, right? So the idea would be that in a much earlier level we would take some transistors and build an AND gate, but now we can miniaturize that down into a box. Right, and now we have an AND gate. You with me?
Yeah.
And we've got some test inputs. So up at the top, we've got a fixed true and false input and a clock pulse, which is just a signal that ticks on and off once a second. Right, and so you've done like basic electronics. You know how this works, right?
Yep.
I can connect these up and get a high output like that. With an AND gate, both of them have to be on for the output to be on. So if you wanted to make a circuit that took 2 inputs, say, and a clock input like this, you could connect these up, and you could say that they have to all be turned on for the output to be turned on. Let's just do a sample, something like this.
So that's kind of achieved nothing.
Yeah, because what you're not getting with your cynicism is the idea that what's missing from this is a puzzle description on the left.
Well, that's
right?
and that's the hard part, isn't
the
it?
Zachtronics style description. Build a circuit that has two inputs, right, and produces these outputs. The actual aims would be specified as like a truth table, right? If you remember your A-level electronics, with these 4 inputs, this is what the output would be, I don't have that. What I have is a much higher level puzzle, which we're going to try and solve in a second. But before we get to that, I'm just dealing with some basics. So Zachtronics would build this up like very, very slowly. The way I see it is that this puzzle level is probably halfway through the game. That's what I was aiming for. It's not the last puzzle in the game, and it's not the first puzzle. It's somewhere in the middle, which means it's quite tricky to demonstrate because obviously it's already pitched at quite a high level. And so you can see our logic gates are basically working. So imagine you've built this circuit, and imagine this solves one particular problem. The neat thing that we can do is if you move to the next board, right, it might look the same, but there's this thing at the top which is a sort of microchip. Now if I select that one and place it down, right, that circuit that's now there is a miniaturized version of that entire board.
That's quite cool. Yeah.
Right? So all that circuitry that's built there is now replicated here, and it's following exactly the same logic, right? And I can have as many of these as I want. So by building a complex circuit here first out of logic gates, and then miniaturizing it, I can build a much more complex circuit on this board by using what I've built. Let's say I built 4 of them and just wired them up in some new way. It doesn't even really particularly matter. And now if I turn our attention to the third board, right, and do the same trick again, plonk that down, you can see that little microchip is now a miniaturized version of that board.
Okay.
Right? And if you look really, really closely on those miniaturized microchips, you'll see there are actually miniaturized microchips on them, which are that board, right? The very first board. And this was the experience that we had in that electronics course, right? You start from the first principles, logic gates. In fact, you actually start even earlier than this. You start with the transistors. And then at each stage, once you've solved a problem, you kind of black box it. Right? You turn it into a black box with inputs and outputs. And then you can use that black box forever again, to produce more complex circuits. So this is the circuit that the game's asking us to build. So if this was a Zachtronics game, you'd have to imagine that wasn't there, and all we were being given was some clues about how to build it. Well, let me go ahead and build it, and while I'm doing that, you can regale us with an interesting story of some kind about how much you hate it when I build electronics games.
Well, I think that the challenge, right, is this bit is not particularly challenging. I have complete confidence that we can build a replica computer within a computer. Where my mind goes is the interplay between the challenges and it becomes a puzzle game, so
well, it is a puzzle game, isn't it?
Well, yeah. And is there...
So the thing about puzzle games is obviously they're content driven, aren't they?
Yes, exactly. There has to be a designed, carefully designed puzzle that you're thinking through, and they're probably there are. You could probably get loads of electronics textbooks and things that would walk you through. Now build this. Now you've done that. Build this.
Yeah, I mean, from a game standpoint, you'd have to make those puzzles rather than it being, in this case, the diagram's there for my own reference. You'd have to, because this is not a puzzle. This is copy a diagram.
That's right.
But you can never ask the player to do this, because even in a sort of, I mean, we've done electronics at degree level. I wouldn't be able to. I can only do this because I can look the circuit up.
Yeah.
So the puzzle has to come from smaller versions of this. Miniaturized versions of this, because you can break down an 8-bit computer very nicely into components, and then you could imagine a series of levels where each of those components is at like one level, like your basic level is your 1 bit of memory, and then it builds and builds and builds until in the latter stages of the game you're dealing with whole modules that you've constructed earlier, you know? I mean, Zachtronics games are always content driven, right? They're always like 30 puzzles of increasing difficulty.
Yeah.
Apart from Darwinia, I don't think we've ever really made or Scansomber, we've never really made a content driven game in that way, have we? We always shy away from it somehow.
Well, Darwinia and Multiwinia and Scanner content driven. You tended to flip flop between the two, you know.
No joke intended.
yeah. Between content driven and systems driven.
Mm.
I mean, it sort of smacks me as edutainment.
Yeah,
do you know what I mean?
I guess it is a little bit, yeah.
It kind of feels like...
But I feel like Zachtronics is that as well, you know? I feel like in Zachtronics, I feel like I have to brush off my assembly programming skills and then actually program, because they don't fake it. Like, they actually do have a really functioning assembly language system. It's emulated, obviously, but there's no shortcuts to it. Like, you often... Even doing basic stuff is very, very hard in that sort of environment. But that's, to a certain brain... That kind of thing is extremely satisfying.
Yeah, and I don't disagree.
It's weird,
isn't
it?
I think it's why you do electronics courses. You know, because when you're in the classroom and you're playing with your first logic, you know, your first circuits and your logic gates and things, you go, "This is really cool." I'm really enjoying the breadboarding and all the rest of it.
I remember you did A-level electronics, didn't you? And I did too. Didn't you? And then we
both...
I
didn't do A-level. I did a BTEC just because of
the
weird way my college worked. But
and then we did it again at degree level. I remember it being really fascinating stuff, right?
Yeah.
I mean, I've finished the first puzzle there, and I've tested it. It's definitely working. So this is essentially latching a value. So it's like a delay. Think of it as like a delay circuit. Mm-hmm. So if you send a high signal in, one clock pulse later, a high signal will pop out the other side, right? And that is how we're going to do a counter. So in the diagram below, this is now 4 of the exact same circuit in a row, tied together. So you can imagine that with a clock pulse coming in on the left, the first one is going to tick endlessly from high, low, high, low, high, low. The second one is going to tick every other clock pulse, right? So the second one is going to go high, high, low, low, high, high, low, low, right? Okay. And then the third one is going to go high, 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 low, 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 high, 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 low, 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 low. Right? It's like a drum beat. So each one is doubling. Each one is doubling the time that it takes to tick over. And when we look at those outputs, that will be a binary counter slowly ticking up, because the first one will be 0, 1, 0, 1, 0, 1. And the next one will be 0, 0, 2, 2, 0, 0, 2, 2. Right? And so by taking all that logic and multiplying it, I can solve the next phase of the puzzle. Right, carry on. Sorry, what were you going to say?
Well, I was just thinking again about, there absolutely being a place for a tool like this to teach electronics, and they must exist, I would imagine, or maybe they don't, because there's just not a lot of money in kind of education software or whatever. But there could be things out there, because the real ones, because there are simulators, aren't there? I'm going to say MATLAB because I don't know what I'm talking about, but there will be electronic.
Why do you think edutainment isn't a game?
Well, that's the. Or
do you not even think
isn't it? That's the thing. I mean, do you have are there enough people out there who want to do this kind of thing? That's what we came back to. We were talking at the start of this. What's the size of the market? How many people would be interested in doing circuit design effectively? See, what it actually is for me is to move it away from just being sandbox circuit design and into entertainment, an entertaining video game. The challenge is the puzzles, that we've already hit on, and that's the rub. The rub is I don't need to see any of this. I just need the notebook with the 30 puzzles, and that will be and looking at those.
I suspect that game exists. I mean, in the possibility space of games, So the failing of this prototype is that I kind of have to provide the solution. But I can't figure out if that's because I jumped in at the middle and didn't start from the beginning. I mean, you would certainly have to expect the player to be pretty skilled to get along with this. Like, this is pretty hard stuff. Like, I have to concentrate quite hard. That's why I was asking you to talk while I was doing it, because I have to concentrate. But it seems to have worked. You can see the 4 lights binary counting there. So the first one ticks on and off. The second one ticks off, on and off every other tick.
Oh yeah.
The third one ticks on every 4 ticks. Right. So that's the numbers 1, 2, 4, and 8. Right, taken care of. So the tricky part is, like, it wouldn't be a game if you were given a manual to build each circuit.
No, that's right.
It would be fun. I still think that would be fun to implement a computer and kind of learn as you were doing it. And I think there was a magic from that degree course, wasn't there, about your slow realization that you now understand every single component that exists in a modern computer. You can see how it's built. And you're kind of giving the players that magic, but Zachtronics never gives you a solution, right? It never says implement this. What Zachtronics gives you is the desired outputs.
You're right.
So it says this is the desired output. So the desired output for this puzzle, it says, right, build a counter. So the desired output would be you have a clock pulse going at once a second, right? From that, make this counter go from 0 upwards. Mm-hmm. And I never figured out how to encode that, in a way that was achievable. Because there's.
How do you mean?
Well, because how do you test? You could test this. I could definitely write a test for this phase, and then that would be one level. Like, the players has to make a latch. You've got an input coming in, and then 1 tick later, I want that same output to come out. That's a classic Zachtronics puzzle, dressed up in electronics right there. But the realization that you need one of these in order to build a binary counter is a leap way beyond most people. Do you get what I mean? There's a logical leap necessary to realize that a chain of binary counters, a chain of latches is a binary counter. And that leap the game would have to make that leap and say, when you want to make a kind of binary counter, you need to make a latch first.
Well, maybe, or I mean, I don't know. Not being an educator, I'd want to have a look at some electronics courses and see how they teach it, because I mean, traditionally the way things are taught is that they explain a concept, they show you how you can kind of put it together, and then they give you some problems, don't they?
Yeah.
So use this bit of kit to do this, and this. There's like stretch targets for you to take it.
You're right. You have to play with it, don't you? And that's the idea. Like, you connect up inputs and you see what happens when I connect that input to here, because this first circuit is a clock ticked chunk of memory. Right? This is one bit of memory with a clock input, which is really fundamental to a computer. So you could do a lot of levels where you're messing with building memory banks that get bigger. Right? You start with 1 bit and then you make 8 bits. Right, and then you have to figure out how to get numbers into those 8 bits. Right? So if you wanted to save a number, an 8-bit number, it's just 8 of these in a line, chained in, and then you put the number in, and then you give it a clock pulse, and that number gets saved. Right, and that's now a memory bank. Now you've got an 8-bit. You've got 1 byte of memory, which is like a building block, and it's like you're assembling these building blocks of a computer. But the same circuit can also be used to build a counter. But the game, I didn't really explain, like, the game doesn't explain, like, what's the context of this, like, why are you building a counter that counts upwards, right? But this is your program counter, right? If you remember from your Turing complete concept, there's always a program counter which is ticking up, and that's the current instruction number, and it's just reading through instructions. It's like the classic Turing tape head moving along the tape. And if a go-to command is just a command that sets the program counter to a specific number. And so now suddenly you have the possibility of jumping to a different point in a program. And so you kind of, you're building the building blocks of a computer from nothing. But in answer to the question of like, how do you make that into an interesting game? You've got to find a way to turn those into interesting hard puzzles, haven't you? Like puzzles that you've got, and there's got to be a ramp as well. There can't be a level where there's a difficulty ramp where you suddenly got to make some massive intuitive leap, because no one's really going to manage that. Right? There's only some people in the world that would make that intuitive leap. And I never really figured out how you would get to that. I never figured out how you would make that leap. But I don't know. Is there a game in implementing a computer? I don't know. And having you walk around it like this, I think this is really cool.
Yeah, I do.
These three boards working together.
Yeah.
We've solved the problem, and now we have this counter building up. And just from like reminding myself how this game worked yesterday, so that I could demonstrate it effectively, it reminded me about how binary works and how logic gates work and how circuits work again, and those parts of my brain all started lighting up. Yeah, and I started remembering why it was that I enjoy it. And I kind of like the fact that this is a miniaturized, is like an integrated circuit of this entire board, and this board is made of 4 integrated circuits, which are this board. I don't know why, but there's something very cool about that, because it makes me think that like 3 or 4 more boards in a row, I could have an entire computer on a single board.
Yeah, I like that. I like that a lot, and I like the idea that you can do the electronics, but without the fiddly faffing around with wires.
Yeah,
like there is a place for that in a classroom, but once you're bored with it, you don't necessarily want to do that. It takes too long.
Well, also, like if you were doing it for real, once you'd made 8 bits of memory, you just have to replicate that same circuit over and over again. Whereas in a video game, you just stamp it down, and it's an exact copy, and it's always going to be correct. Yeah, there's something nice about that in the video game space.
And also, obviously you can just press the VR mode button for this because it's in Unity, and then you get, the vision of people building circuits and doing design in the future because it's, they're in VR.
But you kind of imagine, like, I mean, I don't know, wouldn't you feel a lot of pride walking into this room, right? And it's like this. These circuits are there, like they're the beginning, but then over in that corner, like over here, there's another board. Right, just try and imagine it, and it is a fully functioning 8-bit computer with a screen and a keyboard, right? And you can program it, and you can get it to display up or play Tetris or, and it's all running on emulated silicon in this game world, I guess the question is, is there a sandbox? Is an interesting question here, I mean, I can imagine the game where it's a series of puzzles with defined inputs and outputs, right? And it won't let you complete the puzzle until your outputs match what's required. But that's very specific, isn't it? Like, is there a playground version of this where we kind of let players build arbitrary electronics,
Yeah, I reckon there would be.
Because you'd have to know what you're building, though, wouldn't you? Like digital electronics is always for a purpose. I mean, once you've built a general purpose computer, you don't really need to be at the electronics level anymore. That's the whole point of a general purpose computer, isn't it? That now you've made electronics that can do anything.
Yeah, well, you move into programming, which is a sort of different discipline, isn't it?
Yeah.
But I'm looking at this and I'm thinking about like Microsoft Flight Simulator or Truck Driver. I'm seeing like armies of 40-year-old balding men.
That's right.
Rekindling their
that's exactly who the target market would be. But I tell you, those balding 40-year-old men, they've got a lot of disposable income.
They do, mate. And this is why the game needs to be £100, right? Yeah. Because that's how we signal to them that it's worth paying for.
Yeah. Yeah, I never really figured out how to go from this to an interesting series of puzzles. And I looked at the puzzles that could exist. And I couldn't really see a nice difficulty ramp because in the process of building a computer, there are some stages that are they're not horrendously difficult. They're like I said earlier, there's such a leap of intuition, that it would be unreasonable to expect a player to make that leap. It's just sort of arbitrary, and it's understood now how to build an 8-bit computer, but back in Turing's days, nobody thought like that.
No, they had to work it out. That's it.
Yeah, nobody was thinking about things in that way. And nobody was thinking about memory banks and storing data and things until Turing came along and and had his concept of a universal machine. I mean, it's one of those epic breakthroughs, where one person seems to be so far ahead of the curve in thinking, yeah, and that's Megaprocessor.
Since moving on from Prison Architect, we have spent some time trying to find a new game idea, and it's fair to say that we've not been hugely successful in our quest so far. And this series is looking at the prototypes, the ideas that have come and gone, what we liked about them, what we didn't like about them, what worked, what didn't work. Last month we looked at space bots, didn't we?
Yeah, programmable robots in space.
And there was a lot of love for that concept.
I know that was a popular concept. There's a lot of people who were writing like short essays in the YouTube comments, about how this game could work, and a lot of people had the opinion that the programming side of the robots was actually where the magic of the game was, and that as soon as you started building bases on your own, it kind of became a bit more normal, a bit more standard, and that perhaps what should have happened is that we should have stayed focused on the robot programming and had the robots do all the building for you in response to you issuing commands through the programming language, In other words, stick to the guns of what the game was originally supposed to be, and don't let the player interact with the world other than through programming their robots, which is kind of a hardcore niche concept, rather than coming back to the mainstream concept of construction games, you stay in your little niche and you get even more niche. But I think that they were right. I think that's the right concept.
Well, I was thinking, I had a dream. I woke up thinking about Ant Colony Simulator, and I was just thinking about emergence, and this idea that small behaviours with one can then have this huge, complex,
simple commands for one thing en masse. And we actually did do a little ant colony simulator in Darwinia. Do you remember that?
No, I don't
just
remember
on
that
one
at
of the
all.
levels, or maybe two. There's an ant nest infestation, and they've got their own little brain, and they would send out scouting parties and stuff. And then eventually, when they got into combat, they would send more and more ants out to fight, and then they would send ants out to gather all the fallen souls of the Darwinians and bring them back to the ant nest, and more ants would be born. And they just had a real ant-like look to them, the way that they behaved. It's kind of inhuman.
I can remember them. I can remember the threat, but I can't. I didn't know that there was a lot of simulation going on behind that.
Absolutely, they behave very differently to every other entity in the game, like a hive mind.
I do remember, because you demoed that game to me in BAFTA. We get to go to BAFTA, don't we? Because we're BAFTA award winners.
Just throw that in there.
I'll just drop it in there. We haven't always failed at things. And I do remember, as you kind of expanded out and more of those robots were kind of coming in and doing things, I did think that's very cool.
Mm-hmm. That multiplicative effect.
Yeah.
You just start out really, really small and you end up with something absolutely massive. And you can't really understand the massive thing other than the fact that you know all the individual small steps that you took along the way.
The other thing I wanted to touch on, although you might not want to talk about it, is the first two games that we've looked at have both been sort of epic space builders, and now we've got Dyson Sphere Program number 1 on Steam.
Yeah, I know.
So it's kind of, they must have been really laughing if they'd watched the first couple of Mark and Chris failures of it.
I don't think that. I think it's more, to me, it's more like that was the game that we were making with Order of Magnitude. Yeah. And that was the game we were making again with Spacebots, although our focus was on programming. Like our interaction with the game world was different. But it's a very interesting concept. It's a very interesting idea that the idea that we had was a good one, but we couldn't follow through with it, And this is what the failure class is about, isn't it?
Yeah,
because
exactly.
I have a feeling that most of the game ideas in this failure class are actually really good game ideas. We just couldn't bring them to the end, We couldn't get them over not even the finish line, but we couldn't even get them off the starting blocks in some cases.
Yeah, and that's what I want to work out why. Have you played much of DSP yet?
Only a tiny bit. I haven't played it enough to have any thoughts about it yet. But and I can't wait to play it. It looks really cool. It looks like a really cool game.
Maybe.
Also, but I noticed it as well in Spacebots. Like when we were doing the Spacebots video, and you were going on your tirades about how it just left you cold, and how you hated the idea of just like a Lego construction kit with no real purpose or aim. Like your only aim is to get bigger for the sake of getting bigger, so that you can ultimately build something even bigger. And a lot of the comments were people saying, I would love to do that. I love games that are like that. I love open-ended construction games. See, basically, there's different types of gamers,
Yeah.
And there's no... you're definitely in the world of the gamer that likes to sit and have the AAA blockbuster fed to them, with a spoon, right? Slowly, one giant, perfect AAA morsel fed in one at a time.
Like a baby.
Like a baby, exactly. That's what I was going for.
Intellectual and cultural baby.
Yeah.
He's just spoon-fed.
Exactly.
Give me more Marvel!
So you're really in the Mass Effect world or the Naughty Dog world, or all those like massive AAA blockbuster games. Whereas a lot of players are really into the open-ended construction building game without any real objective. Sometimes there's an objective, like something distant, like launch a rocket in Factorio or build a Dyson sphere or whatever. But really, that's not really the point of the game. Like the point of the game is to mess with systems and build something massive, just for the sake of it, because it's fun. Like, obviously, Steam's marketplace now, our primary marketplace, is like a wildly different place now, even than when we launched Prison Architect.
Yeah.
With this huge volume of games coming out. And to some extent, you could make the business case that it's safer to aim for a very small niche than it is to try and aim for a broad market. Because aiming for a broad market, there's nothing that separates you from all the other enormous games that are already out. Whereas companies that have focused on a niche very well have prospered on Steam because there are so many users that niche is huge.
Yeah.
And so you might think that programming little swarms of robots in space is very nichey, right? Because how many people really are interested in programming? But that niche could be a lot of players.
Yeah.
It could be millions of people. And a games company like Zachtronics has shown that the most hardcore niche games actually do find a market.
Yeah, absolutely. But you've also got that issue of you've got to float above the noise, haven't you? I mean, I don't know what we're up to now. Hundreds of games a week, that are launched. You
30,
can be
30 or 40 a day.
Yeah, you can be the best. Buried in that bunch, but something's got to make you float up to the top, hasn't it? Something's got to, and then the algorithm will start kicking in. And I don't disagree with you, because people play Factorio. They come to Factorio and they go, oh, I love this, and absorb it and enjoy it. And then they go, well, what am I going to play next? I'm going to play DSP, or vice versa. The games will throw the player base sort of around each other, so they'll play one and the algorithm will say, because you like this, you're going to like that. So there's definitely that production kind of benefit, but there has to be something that makes that bubble inflate to start off with. It's like blowing up a balloon, isn't it? I think once the balloon is a certain size, it kind of takes on a bit of a life of its own. If it's good enough, and more people will start being pulled into it and all the rest of it. But it's getting past that initial period.
I think in our 20 years of operating, we've managed to do it twice, I would say. And we did it once with Darwinia, right? By being a sort of zeitgeisty indie moment amongst journalists, but it didn't translate into sales. This is still before Steam was offering the service to non-Steam games, and so although it wasn't a huge seller, it was definitely a sort of like every journalist was talking about that game at the time it came out. And then I think we managed it again with Prison Architect, when we managed to ride that wave of early access hitting Steam, and we had just the right game at just the right time. And it's hard to think when Prison Architect came out that there wasn't a huge flood of Bullfrog style management games out there.
Yeah,
Prison Architect kind of revitalized that genre, and that's the 2 times in 20 years I think we've been on that cusp, of having the right game at the right time, and everything's rolled in our favour.
Well, I mean, just to sort of play devil's advocate, I mean, the DEF CON launch was so successful that all the servers fell over.
Yeah,
You
I
know,
know.
so
But that's because we were
you
running
know,
the server on like a little 486 in our cupboard.
yeah, but in those
We didn't
days,
know what we were doing.
well, yeah, true. But in those days, we did know a little bit about what we were doing. We just didn't expect it to be anywhere near the size that it was.
Yeah.
You know, the level of interest when we flicked the switch for that was. I mean, nowadays it is possible to spin up by 10 times your capacity or 100 times your capacity.
Yeah,
You
just
know,
like that. Yeah.
just like that. You couldn't do that in those days, so you had to kind of make a guess.
I know. Yeah, we
And
used to have to fight with migrating our web server from one
yeah,
box to
yes.
another, didn't we?
And we would, you know, we sold so many copies of DEF CON that we were shut down and offline for like 6 hours or something.
But I remember thinking, like, when Prison Architect came out, that was it had been timed perfectly, accidentally. You know, like there had been a lot of luck involved that we had come up with the game at the right time. You know, and
Yeah.
it's not to take away from the fact that we made that game. But at that moment, like, the Steam marketplace was absolutely ready for early access to open up
Yeah.
with a game like Prison Architect, you know, and its regular updates and everything.
Right, so that was Megaprocessor. Tell us what you think about that in the comments. If you want to play Megaprocessor, you can. Just head over to introversion.co.uk/prototypes. Make a donation. Every penny that we get from this program goes to War Child, which is a fantastic charity helping children who are subject to war all around the world. If you do decide to buy Megaprocessor, you will also get Order of Magnitude and Spacebots, which were the previous two prototypes that we talked about, and all of the other prototypes that we're going to release over the next few months. So it's a cracking deal. So head over there now, just as soon as you have liked and subscribed this video. If you like what we have been talking about, tell us in the comments. If you don't like what we've said, take a long, hard look at yourself and question your life choices. Right, this is Mark and Chris tuning out for another month.